All right, hello everyone. My name is Ethan. I'm with the coach for Major League Hacking this weekend. Um, yeah, I'm here with Dr. Reates and Ali Hassani to go to talk about careers at Ford and different opportunities that they have there. So without further ado, let's get started.
Hey everyone. We both Ellie and I are really excited about being invited to an event like this. I've done some other hackathons with different age groups, but this is pretty cool. One of the things that we learn when we do these kind of hackathons is people don't always think about Ford as a place to be as far as coding. And so I have a couple entry slides to just tell you about where we use code in our operations, which is pretty much everywhere, and then tell you a little bit about my background. So let's see if we can get this going here. So what people might not realize is that cars are massive rolling computers. Many of them have around 50 CPUs in them, which obviously run tons of code. The major component in the vehicle, the engine control unit, is the most powerful unit in the car, but it probably has the most compact code in it. Um, and but a lot of people really don't actually understand that they're becoming more and more electronic, and so um, things like this is one of the things we want to share. And another cool fact to share on the next slide is that our Ford Mustang GT has more lines of code than an actual Lockheed F-22 Raptor plane. And same is true with our Ford F-150 truck, our number one seller for the past 40 some years, is that there's quite a bit of lines of code that are in that. So coding is really, really the foundation in a lot of things that we use, not just in our vehicles, but also in many of our operations, including design and manufacturing, maintenance, support, automation of making the vehicle, processing data, using the cloud. Ali's going to share a little bit about more probably about machine learning and artificial intelligence. It's pretty much going to ease us into this mobility world that we're moving into. And so coders are really, really relevant to Ford. And so that was kind of one of the things I went ahead on. As far as my background, I'm a Ford technical expert at Ford. I've been at Ford for a little over 25 years. And my degrees are in electrical engineering and biomedical engineering is my PhD. And all the schools that I've attended. But what does a biomedical engineer do? Well, I'm part of a department called Digital Cockpit Technologies and Features. And as part of that group, what we do is we create a digital experience for drivers. So up in the upper right, we have basically a full motion, 6 degree of freedom driving simulator where a vehicle sits in the middle of this 24-foot dome. And we surround the vehicle with 360-degree field of view, and the driver interacts with this virtual world. And so we digitally simulate the world. We digitally simulate the many of the models that run it, which again are all based on code. And we have people come in, and this is pretty much the only facility that we have at Ford that we're more interested in what humans do and how they interact in this digital world with the vehicle versus just testing the vehicle, which is what many of our other facilities are dedicated to, the robustness of testing the vehicle, the engines, many of the components. And so what we look at is how people interact with technology in or on the vehicle, such as partially automated vehicles, because the concern is that the driver understands what their role is in the collaboration with the vehicle, or you can even call it the robot. and what the robot's capable of and what the driver's role is. Because in these partially autonomous situations, it means that we have to give control back over to the driver, and the driver needs to understand when and what to do so that we can balance them getting the most out of the automated experience and being safe and not, falling asleep or disengaging such that they can't return to controlling the vehicle. Um, Lots of what I do is around that human-centered, user-centered design area, and like I said, human robot design collaboration. So what I'm going to do next is I'm going to hand it over to Ali, and he's going to tell us a little bit about what he does in his role. And feel free to ask me any questions about, or putting questions in the chat about, if you have questions about what either of us are talking about. Ali?
All right. Thank you, Reates. Just verifying, can you see it on your end?
See you.
All right. Thank you, everyone. Hi, name is Hassani. I am a computer vision and machine learning research engineer at Ford Motor Company. And actually, if anyone's interested, my email is right there. So feel free to go ahead and copy that. And you can contact me at any point to talk about either what I do at Ford or opportunities. A little bit of a background for myself. I actually started at the company in the rotational program 7 years ago. And if anyone's actually interested in Ford, highly advocate going down this route. I was partnered with a mentor and I got to rotate over 5 different areas of the company. And to me, that was kind of invaluable experience. Ironically, I actually did nothing at all to start with AI and ML when I was in college. I was an electrical engineer. But by kind of rotating around, I ended up moving from different areas such as speech recognition, fingerprint app development for an open source tool known as OpenXC. You can actually buy one of those at any point if you're interested. But that was kind of a cool opportunity that I got to go and see what different parts of the company were doing. And then I wound up finding my way actually into the AI department. So if anyone's interested, feel free to contact me. Highly advocate going down that route. But one of the cool things that I've actually done now is I've put some software in the vehicle that are in production. So for example, many of you might have seen that the Tesla Model 3 introduced a content called Phone as a Key. My development team actually worked on that, where you can use Bluetooth triangulation to go and localize the phone in the same way that a key fob works. So that's just kind of an example of how what we do from a general research perspective is look at what new technologies need to be introduced in the world. That's a lot of what Rita's work does. She tries to understand what are customers needing from a pain point, new content, new experience perspective. And then on the advanced side of things, we go forward and put together a roadmap to develop that. In this case, we actually took it a little bit closer to production, but as a general rule of thumb, we'll go ahead and design the software. Let's call it requirements and a recipe to build it, and then we'll validate that on a small scale. Today, I actually work now in the interior sensing group. And so there's a couple of different things that we go on and do over there. We work a lot of service architecture. We do a lot of algorithm design and validation. And my personal favorite part of my job, we're a fun group. We like to make memes. So if we have any time, I'll actually show you a little bit of what we do there. More of just kind of show that Ford actually is a relatively fun place to be. So service architecture design. Many software engineers think that generic design is writing a script or let's call it a program of some sort to go ahead and do an application. But one of the things that really matter when you design your software is how does it scale? So for example, if you take traditional designing of features where you have a whole bunch of different applications that are made independently and are later on fused together, that adds a lot of overhead to your design. And so a big part of what we do before we've ever even touched let's say an algorithm is we need to kind of figure out how do all these things relate to each other. For example, if I want to go ahead and make a driver assistance system and I need to do vehicle tracking in front of me to make sure I avoid collisions, and I also want to make sure that I can go and do hands-free driving down the road, so I need to know what's going on adjacent to me. One could say that I could go ahead and develop different features for collision avoidance as well as one for maintaining hands-free driving. Or one could alternatively say, we can go design a service-oriented architecture where we now have a general perception service for tracking the vehicles in front. And then we can go ahead and design reasoning to go and act upon that to control the vehicle. So a lot of what we do before we even touch any sort of feature, touch any sort of line of code, even think about requirements of what we want to do, we kind of plan out what is the overall design of the system going to be? How can we go ahead and design or platforms that are highly scalable? Some of you may have heard of a process known as Agile. Waterfall is a little bit more traditional for software engineers, where you start with a requirements phase, then you get a prototype and you validate and you keep going forward down the process. Agile is much more iterative. And so, again, it ties all back to what Reates does to start off with what do people need inside of a vehicle? How do we go ahead and understand that? How do we do any sort of analysis of the customer? How do we understand what is missing in the vehicle to enable that? And then we have to divide that down into different parts of software that can enable the building blocks. And in our terminology, that would be a service. Once we have those kind of segmented out, we go verify that the interfaces across the services make sense, and then we model the system as a general virtual piece of software, validate that, and deploy it. So again, before we even talk about any computer vision or machine learning, I think it's critical for people to appreciate from an end-to-end software perspective, our goals are to be scalable, reliable, and make sure that whatever we design has a future pathway to new applications. As far as algorithm development goes, we do a lot of work, at least in my team specifically, on interior sensing. So we do camera-based services to improve the customer experience. And so an example of that, what you can look at some of the competition does, obviously I can't quite tell you what we're doing. You can look around in the automotive space and you can see that hands-free driving is a new piece of software that's pretty common on high-tech vehicles. And there's a camera that monitors the driver to make sure that they're engaged with the road. That would be an example of interior sensing where the camera's on the inside and we need to go ahead and understand who's inside the cabin, what they're doing, so on and so forth. And as a general rule of thumb, there are 4 stages to that. The first one would be we need to go and start off with just general image processing, right? If you have noisy imagery, that gets really hard to do any sort of machine learning on here. And so on the right here, you can see that's a basic example of a smoothing filter. And you can find examples of this. OpenCV is not only a great open source toolbox, but there's tons of open source material out there. So you can kind of just go look at tutorials on what not to do this type of work yourself. But once we have a smooth image, we need to figure out what are we going to do with this? So again, if I'm working on a driver state monitoring team and I want to go and understand what the person's doing inside the car, I need to have some sort of features that can go ahead and describe them. And this right here, that's a generic feature known as histogram of oriented gradients. What you can see is it represents the gradient space, both in terms of magnitude and direction of the person, in this case, an astronaut. This really is a generic process, regardless of what you want to do from an AI/ML perspective. You could do, for example, my very first project was actually in flower classification, and it's the same process. I started off with denoising the image and then defining things that made sense to define one flower from another. In that case, it was color, it was petal length, sepal length, things of that variety. In the case of driver state monitoring, it might make more sense to look at the facial structure of the person to determine the orientation. Once we have some sort of features, we need to train what's known as an AI agent. AI agents really can be anything that you want. In this case, it's a convolutional neural network. And the reason why I like this image here, the first neural networks actually were used by the post office for handwriting recognition. If you kind of think about it, people have varying levels of handwriting quality, and yet the post office seems to, the vast majority of the time, figure out where you're trying to send it and from whom it came from. And so in this case, what you can see is the CNN starts off with the image, CNN standing for convolutional neural network. It projects it into some high dimensional space in a combination of convolutional kernels. So that basically means I go and take some sort of grid and I do a convolution within that to project it into a higher space. And then to reduce the dimensionality, because otherwise we'd end up with millions of parameters, they do what's called a pooling layer in between, often usually just an averaging filter to go ahead and again make it a little bit more tractable to work with. And you do that continuously until you have what are known as some sort of feature space over there. And in this case, we actually end up doing a lot of pre-processing before we deploy it on a network. This right here is a raw image. A convolutional neural network can generate its own features. But if you constrain the problem, if you think of it from saying, you know what, there's a billion different combinations these weights could be, I'm going to go and only provide enough information so that way we reduce it down to 1 million combinations. or model actually gets significantly more precise when we do that. So you can do it either way. You can start off with first doing pre-processing. I generally tend to lean that route. Or if you have just millions and millions of data points, you can take in the image by itself, pass it in, and then from there, a classification layer will go and operate off of it. The goal of that classification layer is to do whatever task you want at hand. If we're talking about driver state monitoring, again, just giving that as an example because that's already in the world, the goal is to figure out head pose. So how is the person looking and engaging with the road in front of them, such that if the vehicle had to resume control to the driver, let's say it's snowing, you can do a safe handover. But having the network by itself is insufficient. We have to be able to deploy that into some sort of embedded compute, which means there's a lot of work that works with runtime optimization. For example, NVIDIA supplies a lot of chips to autonomous vehicles. Various other vendors are out there too. Qualcomm's a big player. TI is a big player. That's just a relative example, and not to say that we are specifically partnered with NVIDIA. As a general rule of thumb, when it comes to runtime optimization, really the best thing you can do is have really efficient code. And so some of you may know of what's called big O notation. That tells you the order of magnitude in terms of the number of operations done based upon the input size. So, for example, if I have a sorting algorithm such as bubble sort, that's going to take on the order of n squared, n being the number of items to sort, to go ahead and complete the algorithm. That's kind of slow when you think of if I pass in a million different things to sort in there. Or I could take it another step further. Another very common algorithm used in introductory software classes would be merge sort. If I do some sort of pre-sorting and breaking things up into smaller steps along the way, I can actually get that to run on log n time instead, or excuse me, n log n time instead of n squared time. Again, small amounts of data doesn't really make a difference, but when you start thinking about the millions of operations the vehicle has to do over its lifetime, that makes a very large impact on that front. And again, we do try to accelerate where possible. So CUDA is probably the most commonly known development toolkit that people use, at least for model development. For example, we may end up just training models on NVIDIA graphic cards because it's easy. There's a lot of resources out there, but for deployment, we might actually use a different framework like Qualcomm Snappy to go ahead and get it to work on automotive hardware. Just trying to show that there's examples of what we want to do, but the main thing is that designing something that run only on a CPU can be very inefficient. And so where possible, we want to go ahead and distribute out computational resources based off of not just runtime, but also power. So if you think of a battery electric vehicle, those are range limited based off of your current consumption. So if I have a whole bunch of very high powered graphic cards over there, we're not necessarily going to have the maximum amount of range. But if we have a combination of a CPU, a graphic card, and maybe a dedicated low power processor, now we can kind of optimize things to go ahead and not just run efficiently, but at the same time maximize our range on the battery electric vehicle. And then lastly, I really view quantization more as just a last resort in terms of reducing runtime. You can get notably better, let's call it training time, if you go ahead and quantize down to uint8s. And so you can see as an example here, those are float point images or integers over there. And these are uint8 numbers over here. And so you can actually get a big benefit off of that in terms of training. And usually there's not too much loss in terms of performance, but the optimization you're going to get from that is much smaller than having just really good code design. And that again starts from the very front. Do we have a good service architecture, making sure all of our things can run in parallel, make sure that we are not redoing computations for the same type of work across applications, picking the right compute to go ahead and deploy this. And then from there, if we're still not hitting our targets, we can do quantization. And if you have any questions about, again, what we're doing in terms of why or how, from a service architecture standpoint or algorithm development, just please put in the chat, and I'll try to get to those. And then this is my favorite part of the job. For me, I'm on what we call the culture cabin over there, and we really do try to go and meet everyone at their own communication language. I communicate best in memes. I'm a software engineer. I'm kind of weird, but that just works for me. And so from that perspective, we have a lot of fun within our group trying to come out with different ways to represent what we're trying to do. Sometimes you need to go ahead and inspire your coworkers. My team is a big fan of the SpongeBob, but everyone has their own different pathway in terms of how they want to communicate that. or sometimes we need to think of new types of different development approaches. In this case, I work in facial liveliness verification for my doctoral dissertation. And so deepfake analysis is one of them. And I think someone may or may not have modified some of my imagery there. So I kind of go back to the code and figure out what's going on there. And with that, would like to open it up, try to see any questions in terms of opportunities at Ford, the culture at Ford. Again, I'm a really big believer in terms of we try to make it a fun place to be, not just in terms of the work you do, but the environment that you're in. And then if you want to go any further in the actual software development process, happy to speak to that as well.
Hey, Allie, that's great information, and I've learned a lot about what you do. Hey, you mentioned the FCG program. Can you define that acronym? Can you tell them what like the length of the program and how it works?
Yeah, sorry, I should have defined that up front. FCG stands for Ford College Graduate Program. Anyone who is within 2 years of completing a degree is eligible to apply. And what it does is it's a 5-rotation program, approximately 30 months, I believe, where you go and get to see different parts of the company and then come back to a home organization for your final position. The reason why I'm a big fan of the program, besides obviously being somewhat biased because I participated in it, I had no idea what I wanted to do coming straight out of college, Reates. I actually was a dual degree. I had a background in EE and electrical engineering. Didn't quite know what I wanted to do. And I started off thinking I wanted to do fundamental circuits, ended up doing a much more software-oriented path. I don't think I would have been exposed to that otherwise. So from that perspective, that's great. The other thing I appreciated about it was you are paired with a mentor, usually a manager of some sort. And so mine, who is Tony Phillips, I believe most of you should be able to find him on LinkedIn if you're interested. He usually does engage with interns and whatnot. He was great in terms of being able to just steer me from a networking perspective. So good people to meet, what's going on within the company in terms of a fun opportunity. Like what's a new hot project that someone's working on that you might want to do as a rotation. So highly advocate for it if you're looking to apply to Ford. In my mind, I do think that there's a lot of benefits to that over necessarily just picking a direct hire position.
Hey, Allie, can you tell us, like, were all your rotations within one city, or Ford's a global company? So can you tell us about opportunities to rotate in other?
Yeah. So in generality, you get to travel for one rotation as part of the FCG program. Obviously, travel is expensive because the company covers your costs from everything, which means you get a car stipend, you get hotel, and so on and so forth. So you only get one rotation, but you will, with rare exception, be able to go travel anywhere that there is a Ford manufacturing plant to do a launch rotation. That actually was my favorite rotation. I was there at Kentucky assembly plant in Kentucky truck plant in Louisville, Kentucky. That is, there's another plant there, Louisville assembly plant. So I get tongue-tied sometimes. But that was great because I got to see how everything is built on the car, how it all works, how it actually breaks down. And being a research engineer, I didn't really have an appreciation for that beforehand. So that was amazing in that I got to be, in my mind, a really fun city for 9 months. You do have opportunities to go and work within a Ford development facility as well. That usually is a little bit harder to negotiate. Your mentor can have some input there, but for certain, everyone has provided budget to do one rotation at a manufacturing facility.
Yeah, that's a great answer. So I know one of the paths is, depending on where you are degree wise, if you're, going to be graduating in the next 2 semesters, then you would apply to a Ford College graduate position on our careers.ford.com website. But if you're after, let's say, your second year, you're entering your second or third year, or if you're going to do, if you're going into a 5th year, if you're entering and you're looking for an internship, there's always opportunities to look in the careers.com.ford website and look at internship opportunities. Once you click on the student link, and there's many different opportunities, and several of them have software engineer on it. And so if you click on those links and you look at what skill sets they're looking for, you'll kind of figure out what's going on. So both Ellie and I happen to be under product development and part of research, but there's lots of software opportunities in many different areas. One area is our Global Data Analytics and Insight Group, or GDIA. Another area is IT. Of course, product development, enterprise connectivity. And we also have our what we call Autonomous Vehicle LLC group as well, which is using lots of coders to help develop our autonomous capabilities. So definitely take a look there as well. So other questions you may have?
Oh, one other thing to piggyback off what you said, Reates. Just because we have a mouthful of organizations at Ford. If you're more interested in doing application development, so let's say you want to work on the Blue Cruise hands-free driving team, that's a product development type role. So you should look for a product development software engineer there. If you like doing basic data analysis, so you want to be a data analyst or do some sort of machine learning work, GDIA, that's the right spot to do that. And if you really like doing back-end development, so just maintaining servers and whatnot, that's more of what IT does. So just because we've got so many different organizations, I figured I'd give a plug in terms of what they do.
Yeah, that's a really good point, Ellie. And some people may want to understand where we're located, because we understand that the hackathon is going on everywhere. So Ford is definitely global. We have our biggest operation, it happens to be in the Detroit area, where our headquarters is, and many of our automotive operations are, but some of our areas as well, especially for those for research, the group that we're part of, we have a location out in Palo Alto on the Stanford campus that we call Greenfield Labs. We have another office in Aachen, Germany, where we work closely with the Cologne University. And so, and we just have many other global automotive operations, just all over the world. So, take a look there wherever you are, globally or worldwide. And you can find out information about where to reach out to Ford and many different areas. So, All right.
So I am not able to directly see the chat while screen sharing. Are there any questions coming in from that side?
There's a couple here. There's one that says, are there any opportunities for younger teens?
Yeah, I guess the question is how young are we talking here? But there's a STEM program for people who are either at the end of high school or very start of college. It's more of a mentorship program than it is a true internship. But I believe if you email STEM@Ford.com, STEM@Ford.com, they can get back to you from the STEM program perspective for younger people.
Cool. And then there was one more other question. I think it was someone just wanted you to repeat your email that you mentioned before.
Yeah. If you could post in the chat for everyone, it is AHASSA37@Ford.com. I'm a talent ambassador, so I'm happy to field any questions. If again, you want to talk about internship opportunities, company culture, what I do, that's all fair game.
And I've also shared the careers@Ford.com link. Ali and I both recruit for Ford on many different areas, and we work with that team, and that team basically pulls from either university-wide opportunities where their career fairs, or they also go to some of the more global events like the Society of Women Engineers, the Grace Hopper Conference, which is a huge computing conference held nationally every year. But we go to many different national-wide conferences as well, and we recruit in that way as well. But what's critical is that you go into the careers@ford.com website, you create a profile, and you take a look at the opportunities there. They're for college student level students and full-time entry positions and direct hire positions.
Cool. So I think that is all we have time for today, and that was all the questions. So if you have any more, be sure to email Allie. The email is in the chat. And with that, we will say goodbye for now. Thank you.
Thanks, everybody. Have fun hacking.
Best of luck.